So I'm back. Thank you again for coming. Good morning. We see still some people logging on, but we will start to be fair to the other people who were on time. Thank you very much for coming. My name is Eva Weber. I'm working as a product marketing manager for the company Abby. And today I'm talking to you in Europe. It's quite late on my side. And I'm very happy to see that we have many people in the webinar. Today we will talk a lot about intelligent technologies, about artificial intelligence and machine learning. And I am here to give you more insight into the implementation of these technologies in our software development kit, Abby Fine Reader Engine. This is a software development kit that you can take, or which you can take and implement into your own applications. The major topic will be the classification with the usage of this Abby Fine Reader Engine. On this occasion, I would like to mention that we have as well ready-made products for classification. If you're interested in that, you can send me an email later on. But the focus of this webinar is really on integrating technologies into your own applications. So I am the right person for you today to listen to if you are, for example, a developer, a product manager, or if you in some way look into possibilities to extend your applications you offer to your clients, to your customers, or that you use internally in your company. And you are looking for fast and an easy way to basically extend application by OCR functionality or by the document classification capabilities. The presentation is a little bit long, I have to say. It's about 1 hour. We will, about 15-20 minutes, have kind of theoretical part, but the second part, or the third part actually of this presentation, will be a live demo where I will demonstrate some of the capabilities. I see very many of our customers who already know us, but some people as well are new in this webinar. So I would like to very shortly introduce our company. Abby is a global provider of content intelligence solution and services. We are a global company. We offer products for end users, for enterprises, but as well the software development kits. This is a department or a product group I'm working for. I'm representing this group, and this will be my focus today. Before we start, a couple of housekeeping issues. I always inform the people that your lines, please, are muted. You cannot ask me questions because with very many, I see right now 130 people in this webinar. So with so many people, we would have a lot of background noise. But I would like to encourage you to ask questions. Like always in my webinars, at least, I have a great support in the background. My colleague, Mrs. Vigilia Kont, she is a technical expert and ready to answer your question. I will be talking, she will be writing in the background. Please use the chat function of your application to ask questions, and ideally you ask right away. We have the experience that we get very many questions at the end, and then we are not able to, or Vigilia is not able to answer them all. This we would like to avoid. We would like to ask, you ask the questions and we answering immediately, but if it doesn't happen, please be assured that we will come back to you later. All the questions will be logged. And if we do not manage to answer during the presentation, we will come back to you later with the answer. So please ask questions. This was very important to me to encourage you. This is today's agenda. As I already mentioned, we will talk a little bit about the Fine Reader Engine 12. This is a product which in the version 12 is on the market since May last year, so almost a year. We will talk about the artificial intelligence technologies and how they help, how they are implemented in Abby Fine Reader Engine. And the major focus is actually usage of the machine learning and artificial intelligence technologies in the classification process. And yes, let's start. Part 1, Abby Fine Reader Engine. What it is, I already mentioned, this is a software development kit which you can implement into your application, that then have the capabilities with the help basically of our technologies to retrieve and access textual information. Very typical usage scenario is document archiving, for example, archiving documents which were scanned in searchable PDF formats. This is, I would say, a classical scenario. But we are not limited, or we do not see only customers within the document management area. We see very many customers increasingly from the area, for example, of automated quality control, machine vision, or robotic process automation, which use text extraction from machine displays and computer screens. So the major focus is text extraction, text processing, but it's not limited only to documents. Still, we see the majority of our customers coming from here, but we have very many customers and use scenarios within the, as I already said, robotic process automation or machine vision. So what you can do with the Abifine Reader Engine, your application will be able basically to extract textual information from scanned documents, from machine vision, from displays, but as well, for example, from photograph documents. What you get, this is kind of overview of the technologies or capabilities your application would receive. Your application would be able to use optical character recognition. This is the extraction of machine printed text, basically, as you would be able, for example, now to scrape the screen you see and extract the text, the presentation I'm showing to you. ICR, intelligent character recognition, that means a recognition of hand-printed text, as you would see, for example, on applications, on exams, or if you apply for to be a client of a bank or of an insurance, you would have to enter some data by hand. This is about this is ICR, intelligent character recognition, extraction, the textual information from documents which were hand-printed into individual spaces. As well, we offer optical mark recognition, which is basically what you can see if your children are doing multiple choice tests. They will cross some answers. This is what is called optical mark. And as well, the barcode recognition of barcodes, OBR. A major area I already mentioned is the document and PDF conversion. So with this SDK, you are able to convert scanned documents, complete document archives, for example, into searchable PDFs. We as well offer basic data extraction and processing of business cards. This is a ready-made algorithm that if you scan or photograph your business card, will be able to extract the data and assign the right values. So for example, you can transfer a scanned business card directly into your Outlook, or your application is able to do it if you use our SDK. And as already mentioned, a big part, a new part, actually quite revolutionary, is the document classification. This SDK can be deployed within cloud and virtual environments. This is quite new in the version 12, and it is available for the Windows and Linux and Mac operating systems. If you're interested in more details, you can go onto our webpage where you can see the technical specification. But one of the kind of unique points is that the software development kit is able to recognize the most languages. Actually, it's the strongest on the market. Over 200, for example, or over 200, I think 206, or in the next week 208 optical character recognition languages will be available, just as a small note. I already mentioned that the version 12 came on the market in May last year. It was updated to the latest OCR technology cycle. For those who have mentioned that we added some new OCR language. We added Farsi as a new language. We improved the recognition of Japanese, for example. We improved layout reconstruction. This was as well possible thanks to the implementation of machine learning and artificial intelligence technologies. We added new PDF formats, some new export formats, for example, HTML5 or PDF2. And already mentioned, now it is possible to use very easily with the new licensing the SDK within cloud environments and virtual environments. And as already mentioned, the document classification was completely redone, readjusted, and it's now using the machine learning and artificial intelligence technologies. And this will be the focus. Yeah, we will see later. As a peek preview, you're actually the first people outside of our company who will learn this news within a couple of weeks. We will have a new release where we will add some additional features. The software development kit get updated regularly with new features and with improvements. We will add the extraction from the machine readable zones, which is important functionality for extracting data from ID cards, for example. We will add some new languages. One of them is the recognition of mathematical formulas. And we will add a new input format. This is quite a big step. Until now, the software development kit was optimized and basically ready to process documents that were photographed or scanned or screenshots, for example. But now we are adding new input formats, which will be Office documents such as Word documents, Excel documents, PowerPoint. So a completely new, a big step on the input format side. But that was only a short kind of peek preview. As I said, this will be happening within the next week. Yeah, it will be big step. Now I would like to move actually to the quite exciting and interesting part, artificial intelligence technologies in ABE Fine Reader Engine. And I will start with kind of general introduction. What is artificial intelligence? There are very many definitions. And what is the difference between artificial intelligence and machine learning? And shortly put, artificial intelligence actually is basically an ability of a computer to learn, to observe, and to make decisions. And to gain this capability, the technologies of machine learning are used. So this is basically the difference. Machine learning is more or less the way to achieve the artificial intelligence, the way or the way to achieve the ability to make decision. Artificial intelligence is about making decision, observing, analyzing data, deciding. So, and the question is why we are doing all of this, why we are using machine learning and artificial intelligence in this software development set. By using those algorithms, we were able to improve the accuracy, the recognition accuracy, one of the most important points in OCR and text recognition is the accuracy. The most accurate results are important in order to save your time. It doesn't help if you have fast recognition but not accurate recognition. We improved object detection. We improved layout reconstruction, which means basically the document which was transformed and converted needs to be reconstructed at the end in the same layout with the same formatting as well, improved thanks to artificial intelligence technologies. And as already mentioned, we completely kind of reinvented and re-implemented the classification process in this version 12. So now I will move to a couple of examples of the artificial intelligence technologies. One of them is the usage of the convolutional neural networks. And what are convolutional neural networks? These are basically trainable deep learning algorithms that are used for processing images. And you probably know the possibilities or the recognition of faces, for example. Google is using a lot convolutional neural network, or any kind of classification or decision about image processing can actually benefit from the convolutional neural network. A convolutional neural network are inspired and kind of almost working or acting as a human brain. And if you imagine yourself or your children, how they learn by observation, by processing information, similarly, the convolutional neural network as well are observing and learning, which means that you have to feed them a lot of data. And by feeding these algorithms a lot of data, the algorithms will be able then to, as I already mentioned, to make own decision, qualified decision, even with objects it has not seen before. For us, for our technology, we are working with documents, we are working with texts, we are not working with faces or photographs of people or other objects. So we actually use this convolutional neural network and provided it hundreds, thousands of documents, and we taught this CNN, this is abbreviation, how to, if you want to put it simple, how to look at documents, how to extract features, how to extract information and detect patterns in documents. And what is the big advantage right now for us? First, during the recognition steps, basically during the, or even before the recognition, the technology needs to decide what are objects, diagrams, and pictures on a page, and what is the actual text, because only the text will be then recognized and extracted. And this is already kind of classification step on the page. You know, if I'm the algorithm, I need to classify the content of the page into images, into diagrams, and into text. And this is where we use the convolutional neural network. And the second area is in the classification of documents. If there is a necessity to sort documents into different classes, because we pre-train this convolutional neural network, you as a user or as a developer need only a handful of documents, 5 documents per class, to train the technology on your own documents, because if you want, the major step, the major work was already done by us. So this is a very, very important technology. The another technology we are using, especially as well for recognition and classification, are the support vector machines. Support vector machines are used for separating categories of objects, which basically is classification. And they are based on idea of of finding a hyperplane, a kind of division of objects into 2 categories. The idea is to find a most possible distance of those 2 categories, basically, and sort objects, if I put it generally, into 2 categories and keeping them as far apart as possible, basically, but still being on the right side of the categories. The support vector machines have the big advantage that they do not work only for 2-dimensional characters or attributes, but for multidimensional attributes. And in FineReader Engine, we use them during the recognition step, where we basically use the support vector machines to detect types of text, to recognize if this is a European, those are European languages. In this sense, of course, English is one of these European language, or even if I talk to USA today, I know, or the Asian languages, which I have completely different systems. So Chinese, Japanese, or Korean go into one category with the help of the support vector machines, and the European languages go into the other categories. And then in the next step, the automatic language detection will start. But the technology already pre-sorted the possibilities with the help of support vector machines. And during the classification, the support vector machines are as well used to verify, basically to detected document classes. Another technology we are using in the Abbey FineReader Engine is gradient boosting. Gradient boosting is technology used for mainly for document layout reconstruction for us and for document formatting during the synthesis step. Gradient boosting is basically kind of a step-by-step iterative machine learning process where the technologist tries kind of step-by-step to close a gap and minimize basically the distance to a target function. And finally, the engine, as mentioned, it is used basically during the document analysis, when the document gets analyzed, to detect document boundaries. Why it is important? This is especially important, for example, if you do not scan documents but photograph documents. Usually, the document boundary is somehow not right. You can see part of your desk, for example, or your coffee cup on the photo. It is really important first to detect where the document, the relevant document is placed, and what is the document boundary before the technology start the actual recognition. This is called pre-processing and document analysis. And during the last step, basically during the document synthesis, after everything is done, after the technology extract the text and recognize the text, it will put the document together in the requested format, for example, Word or PDF. And because of the gradient boosting technologies, it was able to understand the document level entities. It is now able to precisely reconstruct the document, for example, to put the text back into paragraphs, to put the pages in the right order, and similar parts. Another technology, and this will be shortly, I hope you're still with me, is the usage of probabilistic graphical models. Those probabilistic graphical models, called PGM, provide an approach to deal with uncertain situation, uncertainty, with the use basically of statistic and probabilistic theory, and we use them in the Binaries, the engine, to detect orientation of Asian characters, Asian languages, basically Chinese, Japanese, and Korean. And one of the last, or the very last one I want to mention before we actually go to the live demo, is the transfer learning. Transfer learning technology is very, very important for us. What it is, that transfer learning basically means that if you or computer are able to solve one task with the transfer learning technology, you are able to solve a similar task. So if it's you or your husband or child, if you, for example, learned how to cook potatoes, you will be able, with the knowledge you gain during the process, during the cooking course, to cook as well carrots, for example. This is very simple explained transfer learning, and for us, for our technology, this is very important because as you will see, and I already mentioned this, we pre-trained the classifiers, we pre-trained the technology on very many documents, and with the transfer learning basically enables the technology to use the gained knowledge and learn very quickly on your documents, and you will see it quickly or shortly in action. So again, that allows the user basically to train the image classifier on their own documents without the need to provide a large amount of documents, hundreds of thousands of documents. Okay, so, and I think this is the last part. I will just shortly check the time. Yeah, about 25 minutes. This was the last part of the kind of theoretical introduction. And I think this is almost one of the last slides. So why we are using a machine learning in document classification, we move to the specific topic of document classification. And the simple answer is on the right-hand side. With the machine learning, we are able to provide the users a very granular and scalable classification. What it means, I already mentioned the machine learning and transfer learning and convolutional neural networks and all those very smart technologies enable basically the computer to detect and define very many features, very many kind of patterns, which actually, if you or me would look at the documents, possibly would not even see. So if you would categorize documents, if you would manually sort documents, you would be able to do it to a certain level, to see certain certain features, certain patterns on the documents, and you would see, okay, this is an invoice, and the other one is a contract, because you learned it and you know this. But maybe you would not be able to do a deeper distinguishing of the documents, because there might be features which are really invisible to your eye, but the computer is able to detect them and to qualify them and to make this decision. So with machine learning, with these algorithms, we are able really to take into account a very large amount of document features, to detect very subtle, very almost invisible differences among document classes, and even define very flexibly the classes. And you will see it later, that, for example, visually very similar documents can be still identified as belonging into two different classes, and vice versa. Visually very different documents can belong to the same class. It would be, for example, if you would like to collect ID cards, ID documents, and you have 50 states in the US, and we have very many countries here in Europe. And for example, even in my purse, I'm from Czech Republic, so I have a Czech passport, but I have a German driver's license, and yeah, you have American passport, and as long as we would present to our technology enough samples of those documents, all of those documents, even if they are visually very different, they are in different languages, could be identified as an ID document. And this is the example of visually different documents which can be detected as belonging to the same class, and I will show you shortly an example. Okay, what are we using in our technology for classification? We have two types of classifiers. One is the image classifier, one is text classifier. The image classifier is working with visual features. And it's distinguishing the categories visually. So it's not actually using the OCR information from the text, but it's working only with the visual appearance. Similarly, if you open an envelope and briefly look at the document, and you see from the shape of it what kind of document it is, if it's an invoice or a letter from a friend. This image classifier is using the pre-trained convolutional neural network, and I already mentioned there is no OCR step, which means that it's a little bit faster, because OCR is a resource hungry algorithm. So this image classifier is a little bit faster than the text classifier. The text classifier on the right-hand side, as already mentioned, is working with text, not with the visual appearance, but with the text, with the actual content. So as a first step, the OCR process needs to run. And the text classifier uses another ABI technology. It's an ABI natural language classifier, which basically works with really the meaning and the content of the text. And those classifiers can be used individually, but they can be as well combined to basically increase the classification accuracy. So how is the process? And please remember a little bit this slide. I tried to split it into, it is actually a three-step process, while the two steps belong together. So the classification, how it happens in 3 steps. First, as I already mentioned, we have self-learning algorithms here, and we need to teach it, which means we need to give a couple of examples. So the required document classes are defined in these steps, and a couple of samples per category needs to be identified. This is called basically the creation of the training data set. And with this training data set, the next step will happen. The classification model will be trained. For the image classifier, we will use the convolutional neural network, and for the text classifier, the natural language classifier will be used basically to detect parameters and patterns and features which are typical for these documents. The classification model will be trained, and I put a slight line here I hope you can see it. It's here basically because this part on the left-hand side is the preparation. And then we can go into the deployment, into the actual classification when the classification, the trained classification model will be deployed in the project and the classification will happen. I have a small short note here that it is possible basically to continuously improve the classification model. For example, when you detect or your customer detects wrongly classified documents, those documents can be then fed back into the or implement into the training data set, and the model can be retrained, improved on ongoing base. This basically the developer would have to kind of implement himself, but it is possible to retrain and improve the classification model continuously to improve the results. And yeah, this is definitely end of my kind of theoretical introduction, and I will now show you the classification in action. So I will close the presentation. Just a second. And what I'm going to show you will be a precompiled sample, which is part of the ABIFINE Reader engine. I will show it from scratch. So this is basically the library of precompiled samples. Those samples you can use for free and use them in your own applications. And if we go for the classification, I can run the sample. And this is basically, I hope I cannot, unfortunately, I cannot make it any bigger. I will close this. But this is basically the precompiled sample where you can create classification model, train it, and use it for classification. Before I completely start with this, I will show you a couple of documents. I will start with the image classifier. And I already said we need to do 3 steps. We need to create the training data. We need to create the classification model and train it. And then we can start using it in the production. So this is basically the third part, the production. I have here a set of documents which I want in the end, after I created the classification model, I want to have these documents sorted. And I will show you a little bit the documents. Those were scanned in different directions. Some of them are right, some of them are wrong. Here we have some invoices. This, for example, is just a letter. We have some agreements, contracts, but we have as well a couple of brochures. This is basically the set of documents, the batch of documents I want to classify it at the end. And what I have to do, I have to think about what I want to achieve. So in my scenario right now, I decided that I want to have these documents, those 61 documents, classified into 3 categories. As already mentioned, we have some invoices, we have contracts. So I will have a category invoices, I will have category contracts, and then I have some letters, and I have as well, this is a letter, for example, and I have as well some brochures. I decided right now those 2 visually very different document categories to put them into one class. I would call them marketing materials, and I want to have in this category marketing materials, brochures and letters. Yeah, in this situation. So this is where I start, and I need to create the classification model. So as already mentioned, we will create the classification model. We will correct image orientation. I'm just describing in case you have small screen what we are going to do. We do not need to recognize the text because this will be an image classifier. And we define the category. So if you remember, we said we want to have invoices. We will have invoices. Then we will have category called contracts. And then we will have a category called marketing materials. Okay, we have 3 categories, and now we will add images. Add image, and now I have to find the example of, I need to find examples of these images. I'm working with the image classifier, and again, I said I have the production batch. This is what I showed you before, and I already prepared kind of examples of the images. And what do we do now? We are in invoices, so let's look for invoices. And I have 9 examples of invoices here. Again, show you a little bit. I have 3 vendors. So I, in my training batch, my training data, I decided to put 3 invoices per vendor, altogether 9 invoices. So what I'm doing right now, I'm creating the set of data, and the technology is importing the samples, as already said, and I do not need so many. Yeah, I do not need so many because the classifier is pre-trained. Couple of contracts. I have 4 examples of contracts. I will feed them, basically. I will import them. And in the 3rd category, marketing materials, I will add images from the category marketing materials I already mentioned before. Those are some letters and some brochures. Visually very different documents, but as long as I am samples, I took a little bit more because this is really more challenging. As long as I have samples, the technology using transfer learning will detect features and examples. Sorry, I probably did not mark them all. So I need to mark all the documents. And all the documents will be now inserted as sample documents for teaching, for learning. And when it is done, I will show you how to train the model. So this is the step 1. If you remember, 3 steps. This is the step 1. We are creating the training data set. So we have some examples in marketing materials, we have some examples in contracts, we have some examples in invoices, and now we will save the training data in the image classifier classification model. I have already some information here when I was training this, but this we will call this training data. I will just use training data. This will be for 3 categories. And today is the 21st of March 2019. So this is my training data set. I am saving it, and I can as well use it later. So it's saved. Next, we move to the step number 2. We will train the classification model. This will be an image classifier. And here it is interesting that there is an opportunity already to kind of check the quality of the classification. There is a cross-validation test or step during the training. If you have enough document samples, the technology would internally split this amount of documents into whatever you tell. Yeah, fault counts right now I have 3, and use only part for the training and the remaining part for a first internal test. And this is what I'm going to do right now. And I go for train. For training, I say train, and I get as a first internal check this what is called confusion matrix. And the confusion matrix is basically saying, dear Eva, I took a part of your internal documents. I trained on one part and I tested on the remaining part. And whatever I said, I found one contract. I'm predicting this is a contract, and yes, actually I know that you put it into contract. And I found 3 invoices. If you remember, we put in 9, so 3 invoices were used for testing, and all those predicted invoices are invoices. So this is a kind of ideal convolution confusion matrix, because all the tested documents showed into the right categories. It is a good sign. Okay, we saved the classification model. I put it here, and those were training data for 3 categories. And now I will use actually this. This is classification model for 3 categories. I'm saving it. Automatically, when I saved it, it is actually here chosen as a model for classification. In theory, I can train very many classification models and load them and use them for different tasks or in different situations. Okay, so what we did, we detected or defined the training data. We trained the classification model. No, we have to go for the batch. And if you remember, those were the production batch mixed documents. We have 61 documents. I will copy the address to this folder and put it here. And to be on this, sorry, I better do it again because I seem to have a mistake. It doesn't exist. Okay. So this is my production batch. I don't know why my again. No. So for some reason, I was not able to check the batch, but I clicked on run classification, and the classification process start running. If you remember, I have 61 documents. So you can see that the technology, I'm right now using my personal computer, not a specific machines. It takes some computer resources, but as you can still see, the classification is document by document running. We are in about 1/3 of the documents is right now already through. And again, reminder, we decided to have 3 categories. And I already see I made a small mistake, but I will correct it shortly. We decided to sort the documents into 3 categories. And those categories should be contracts, invoices, and then the marketing materials. And now we can see how the results will be. If we are not happy, we can correct some parameters. The training data, the first step actually can be, we had, when we were presenting this, always the question, what will happen with the models and with the training data, if the data is kind of the documents used for the training data is as well, if the training data and the models can be actually given to some other people, the data is encrypted. So I will show you the results. I made a small mistake. I realized once I started the classification that I forgot to say correct image orientation. So I have only 3 contracts here and only 20 invoices, and everything else was put into the marketing material, which is a little bit too much. Some of the documents were scanned incorrectly, and I should have actually correct the image orientation. So I will rerun the classification, and hopefully I will get more than 3 contracts. I know that there should be actually 4. And I'm as well expecting more invoices. I had actually 27 invoices in my batch. But I think the idea is already clear. We created the examples, basically, the samples document. We trained the classification model. And now we are deploying this classification model in action. And the classification itself, now I had to basically restart it with correcting the image orientation. I confused the technology a lot before. So already mentioned, it is possible, basically, this classification model is encrypted. There are no documents behind it which could be read or somehow identified. There is no problem with data protection or with any difficulties. Especially in Europe, we have very strong law for data protection. We had a lot of such questions. This is not a problem to use it. Another question, actually, we already have was how many categories can be actually defined, and my colleague Vigilia is reporting the number is no more, please, than 500 categories. So there is really an opportunity to use very many categories, but it should not be more than 500. The classification is almost done, and I will let it go to the end and then show you another step. Okay. So you can see the classification is almost done. In the marketing materials, this is the first category. We see all the letters, but as well the visually very different PDF documents were added into this category. Why? Because we said the classification model, please put letters and the marketing brochures into one category. So again, this is last document is coming. And we have 4 contracts, we have invoices, and we have the marketing materials, letters, and the 4 invoices. What happened if I right now find out that I made a mistake and actually the marketing materials having letters and brochures into the same category was not such a good idea? In this case, I need to retrain the classification model. So what I will do, I will create a new model and rerun the classification. Right now, I decided actually that I think it will be a good idea not to have only 3 categories, but to have 4 categories. What do I have to do? I have to redefine the training data. But I'm making only a small change right now. So I will load the training data I prepared before, image classification model, and I have this, what I did before, training data TD categories. I will open it. I see, okay, I have the invoices. Yes, I remember there were 9 invoices, and contracts. Yes, we had 4 contracts, and then we had the marketing materials, but this idea was not good. I'm going to delete this category. Yes, I'm going to delete it, and I would add another category, and this time I'm going to call the category letters, and I will have another category which I'm going to call leaflets. And I think this is a better solution for me and my company. So I have invoices, yes, they are in, contracts are in, but letters, I have to add samples. And image classifier, training data. If you remember, we had them all mixed. Okay, this will be a little bit tricky now, but those are letters, and the letters are only those examples. I have to be very careful not to get anything else, but those letters will get as samples into the category letter. And those are 9 pieces of letters, samples here. And then I will, with the same care, kind of add the leaflets. So I'm right now defining a new training data set. Done. At image, I know as I already said, I will be carefully selecting only examples of the brochures, and I will as well add them into the training data set of brochures. And with this new training data set, I will train a new classification model. So in the previous presentation or previous demonstration, we sorted the documents into 3 categories, and now we will sort them into 4 categories because we are retraining the classification model. And the training data set is now done. All the information is encrypted. Save training data. Image classifier, classification model. This will be a training data for 4 categories. I have to save it in case I need it later. Save. And now I will use the image classifier again. I will cross-validate to see if everything is okay. I can decide if I want to train for high recall or high precision. Again, you can already see that I have 4 categories, and the confusion matrix looks good. Everything which was defined as letter is actually a letter. What was identified as leaflet is actually a leaflet. I have already 1 category more. I will save the trained model, which now will be called classification model for 4 categories. Just using it, it's faster. 4 categories, and I am done. The mixed document batch is still there. So we had 3 categories before, but now we are classifying into 4 categories. The convolutional neural network was quickly able to use a transfer learning mechanism and learn about the features about those documents I am using. What it means for you, basically, that the technology can be quickly trained. As you can see, it's very, very quickly on a couple of documents, how to detect features on your documents and classify your documents. And you can already see the good news is we have the category letters, what we added newly. The invoices, yes, we had it before, and contracts we had as well before. And right now, actually the category letters is filling up. There are quite many letters. We should get up to 26 letters actually here, and then we will see the 4 contracts we already saw before and 27 invoices, because the number of contracts and number of invoices, they have not changed. The only change is that we do not see now the category marketing materials with the mixed letters and brochures, but we split them into 2, into letters and into the leaflets. So we are almost done, and this is basically the overview about the image classifier. In the next presentation, when this demo is finished, I will show you the usage of the textual classifier, the text classifier. This is used in situation where the visual distinction is not possible. With these examples of documents, it was not necessary to look into the text, because the visual information about the documents was actually enough. And this was a bit faster. It was enough for the technology to basically have a short look, if you want, and decide into which category the document belongs to. So I will wait for the remaining brochures to arrive in the right category. I'm at the document 58, 59, 60. And we are finished. And if I make it a little bit bigger, hopefully you can see it. You see that we have 4 leaflets. We have 26 letters. This is the category which was previously called marketing material with marketing materials with 30 documents altogether. We still have 27 invoices, which were categorized as such, and 4 contracts. So this was basically the situation, or the model training for the visual classifier. And as a second part, and this will be end of the presentation almost, I will show you the textual classifier. Again, this is in situation when the visual information is not enough, and you really, even as as a person, you would have to really look into the text to read a document to find out what it is about. So again, we can create a new model, but I would to speed up a little bit. So I already created the model for the textual classifier before. So this time I am going to load the prepared model. We go to the text classifier. And again, I already said, I already trained the classification model. I created training data set before, and now I created classification model. So we will insert it. So in this situation, I basically, for you at least, I do not bother you with the training data set. I did it before. And I will as well show you the documents we want to classify. And we are going to use the text classifier. This is the production batch. And in the production batch, I will try to show you. In the production batch, I have very many documents. You should see it, which are almost the same, at least at the first look. And if you want to know how to classify the document, you really have to go and read it and find out what the document is about. I measured it myself. I needed to skim it quickly, at least 20 seconds, up to 1 minute, to find out what the document is about. So in case if you, for example, would serve a call center where each specialist in the call center would get documents to a certain topic, you would need to pre-classify those documents very quickly. In this production batch, I have 50 documents. And those 50 documents, as already mentioned, look almost identically. They are basically a text to a certain topic. I want to classify those documents. Those documents will be classified into 5 categories. What I did, I pre-trained the classification model, this time a textual classification model. I will just check if I have the right document set, and I will run the classification. I will run the classification. What is happening now? The technology first for you invisible step is doing the OCRs, is applying our optical character recognition to extract the text, and then it will analyze the text and try to find out what is the meaning of the text, what document category this document basically belongs to. And I have 50 documents. In ideal scenario, I would get here 10 documents per document class. And already when we trained the classification model and we looked at the confusion matrix, we saw small mistakes. We saw small indication that not all the test documents were actually categorized absolutely 100% correctly. But we still decided to try and to see how the classification results are. These classifications results will show small mistakes, and this is basically no problem to optimize the demo to show you absolutely perfect results. But on purpose, I didn't want to do it because I wanted to show you how you can improve the classification results by a regular update of the classification model. And you can see that we have, I see the category, there are 5 categories: category cars, category medicine, category space, category electronics, and I think a category healthcare. And we classified right now about 2/3 of those documents. Again, this takes a little bit more time. You would need a computer which has quite a power, because the OCR, I already said, the OCR processing is a little bit resource hungry. There is a lot of computer power needed. If you imagine that this is basically a call center, all the documents which get categorized properly, this is of course fine and everybody is happy, but it can happen that some of the documents end up at at a different desk, basically in a different folder, and the person who will pick them up will actually see that those documents do not belong to them. And in this situation, it is possible to implement a specific feedback mechanism where you, for example, as you can see, my computer is done now, and as you can see, I have only 9 documents for medicine. I have 10 for sports, for hockey. I have 12 for space, which is wrong. If you have good eyes and a good computer, you would see that I have actually name tags with the documents, but the technology is actually not working with the file names, only with the content of the document. And 2 documents are wrong. 2 documents are wrong. This one is called electronics and this one is called medicine, but the category is called space. So what happened here, we had a mistake, basically. Even we as humans can make a mistake and misplace a document. The technology, it happened the same. The technology misplaced 2 documents. And what I would do now, I would actually identify those 2 documents, which probably somebody would report them if they arrive by email or by another routing at his desk. He would drop them into a special folder and say, hey, this doesn't belong to me. And what we would do then, we would basically use those 2 documents and retrain the classification model. Retrain it, giving those 2 examples and saying the technology basically, hey, those two documents were misplaced, and please learn on them, and next time you would know better. So I, knowing this, when I was preparing this presentation, I trained another classification model with those 2 misplaced documents. I do not need to correct the image orientation because those documents are fine. So now what I did, as you can see, I uploaded retrained classification model where I use the 2 misplaced documents. And the technology is having a second look, basically, with the new classification model. Again, this is an example how you can use, where you can basically implement a feedback, kind of feedback routine, where wrongly classified documents can be used to continuously improve and learn, basically teach the classification process, the classification model, the new features and new patterns, which it may be overlooked before. Okay, so again, the process is running, and since I'm almost at the end of my presentation, my colleague is sitting in another room, but I hope you place your question, you write your questions, and she's answering. If you do not receive immediately an answer, again, please be assured that you will definitely hear from us later. We will collect your question and when we ask them. But if you haven't done so, place your question right now. You can as well write us some feedback or whatever you want us to let us know. You can write us as well feedback if you like the presentation, what you did not like, what we should make better. We are very, very interested in your feedback. And right now, 33 documents out of 50 are already categorized. Again, I needed between 20 seconds and 1 minute per document to read the content and to find out. It would take me, in this case, something about 1 hour to categorize the documents, the 50 documents, and I would be very, very tired for sure after that. The technology is already almost done. We are at number 43, 44, and we already see that this time all the documents that belong to the category electronics, 10 documents are here. We have 10 documents of the sports, the hockey. We have 10 documents related to medicine, the space documents as well, 10. And there is another one which is called cars or autos in Europe. This time we have a perfect classification result with the retrained document based on the mistakes we discovered before. Okay, so this is actually the last part of the demo. I will return to my presentation. and see if we have more to say, but actually we are almost at the end. So this is kind of summary. Machine learning based document classification with Abi-Fine Reader Engine. As if I should summarize, those are self-learning iterative algorithms for granular and precise document classification. I already mentioned we can or you can establish up to 500 categories or subcategories as long as you have enough document samples. As you have enough means something between 5 and 8. That's not so much. It is possible, and you can continuously improve the classification model. It doesn't need to be perfect from the very start. Very often you have then new classes or new document samples. The system allows the flexibility to adjust and improve over the time. So this is the end of my presentation. Thank you very much for your attention. I will leave the application open for a couple of minutes just to give you the possibility to ask your questions. Some of the questions I was already mentioning. Another question that was arriving was about the text classifier. If there is a possibility to add keywords and kind of improve the classification. This is not possible and not needed. So the kind of guiding the technology with the help of some kind of keywords is a little bit, I don't want to say old-fashioned, but it's another approach. In our technology, what I was demonstrating, the technology is actually smart enough to detect it itself. So there is no option basically to add keywords, because the technology would find the keywords, the relevant keywords, we call it features actually, not anymore keywords, in the text itself. I already mentioned the training data and the model. This I can as well show you again. The information is encrypted, so there is no problem with with any data protection liability, for example, because no, no, my computer is a little bit on strike. Let's see if I can open something else. Okay, Explorer is it's not supporting me right now. Otherwise, I would show you. If you open, basically, you can test it yourself. If you open the for example, with some program, if you open the data training data set or the classification model, you basically do not see anything. There is no possibility to kind of reconstruct the content of the training documents, for example. All this is actually no problem. Yes, so I promised 1 hour, and we are a little bit over. So thank you very much for your attention. Please again either send us an email. My name is Weber, Eva Weber, at ebi.com, my surname, or you just put a comment right now into the chat, because after a couple of minutes, when we close the presentation, we will actually get the list of your questions. I was as well told not to forget to tell you that you will receive a recording of this presentation. You do not need to take notes or something. I think within 24 hours or even faster, my colleague will actually kind of edit this file and prepare it for sending, and then you will receive a link where you can listen to the presentation again, or share it with your colleagues or whatever. If you would like to test yourself, please go to our webpage, ebi.com, to the area for developers, and find the Abi-Fine Reader Engine. There is a possibility to get a free trial. Immediately you receive an email with a 30 days trials, but it is as well possible to get a longer trials for 60 days. In that case, probably the best way would be to send me an email, and I would arrange it for you. So with these words, I would like to thank you for your attention. attention. It was a little bit long. Have a nice day. For us, it's already evening here we are talking to you from Germany today. And I hope you enjoyed the presentation and have a nice day. Thank you very much. Bye-bye.